Welcome back. My name is Mrs. Horseman, and today we are going to talk more about movement of molecules across the membrane. Specifically, we are going to talk about active transport. So in the last video that you watched, you should have been learning about passive transport and how things move from high concentration to low concentration across the membrane without the use of energy. Today we're going to talk about the flip side of that. So we're going to talk about how things move across the membrane, but it's not always so easy. So it's going to require some energy for the cell to do that. Okay, so today we're going to be talking about active transport. Anything that uses, any type of active transport is going to be something that uses energy. So let's take a second to talk about how our cells use energy, okay? Cells use an energy currency called ATP, adenosine triphosphate, and this molecule is like a little battery, and that little battery is going to donate energy to chemical processes, and then it's going to go back and recharge, and it's going to be available for more energy for that cell, and it's just going to keep doing that cyclical kind of thing, okay? So when the ATP molecule attaches to a protein, it's going to provide the energy to move things across the membrane that the cell needs. So here's a picture of an ATP molecule. We'll talk more about this when we talk about the energy of the cell, but what I really need you to understand is this ATP molecule provides energy. So anytime you see one of these little starburst kind of things in a picture, I want you to automatically think that energy is being used, okay? So ATP is our energy molecule, and the first time we're going to see it is when we talk about protein pumps. Sometimes molecules have to move against the concentration gradient. So for whatever reason, the cell needs to move things from low concentration to high concentration. And I think of somebody trying to push a great big ball up a hill. It's going to be really hard. It's going up against the gradient of that hill, and it's going to use energy from whoever's pushing that ball up the hill. I also think of, because you know I like to use visuals, I also think of if I'm in my room and I'm trying to get to the office and the bell rings from lunch. So everybody's walking back to the classrooms and I'm trying to get up to the office. So I'm walking against the flow of traffic, okay? It's going to be really hard for me to do that, and it's going to take a lot more energy than if I was just walking down the hall with nobody in it. All right, so when I think of concentration gradients and moving from low concentration to high concentration, I think of moving against the flow of traffic. Lots of energy. I'm pushing against where everybody else is going. All right, so in this case, ATP molecules give up their energy to the protein, which then allows that protein to pump, actively use energy to push molecules against the concentration gradient. One example that's really popular to use when we're talking about protein pumps is the Sodium-Potassium Pump. Okay, I'm going to show you two different pictures. I really like this picture because it's actually showing the concentration gradient. Okay, so if you look here, this is the extracellular fluid, this is the outside of the cell, this is the cytoplasm, the inside of the cell, and then this is the cell membrane that wraps all the way around the cell, and then this is our protein. Okay, so if you look, these are ions. The yellow ones are sodium ions, and the greenish ones are potassium ions. And remember, if it's an ion, it means it has a charge. And in these cases, it's a positive charge, okay? So because it has a charge, because it's an ion, it can't move across that lipid membrane by itself because the fat part is nonpolar and it doesn't like it. So it's going to kick those ions back out. But the cell really needs to be able to move them. So what it does is it uses a protein to do that. A protein and energy, and it's going to be able to move those molecules, in this case, against the concentration gradient. If you look here, there's a bunch of pluses on the outside, and then there's a bunch of minuses on the inside. Your cells like to keep a slight positive charge on the outside of the cell and a slightly negative charge on the inside of the cell. And it actually helps cells do things like move electrical impulses. For instance, nerve cells, when they're trying to send a signal from one cell to another, those electrical impulses pass a lot faster because of this positive and negative sides of the membrane. So now that we saw that, if you look, there's more potassium, more of the K's on the inside of the cell, and more of the sodiums, more of the NAs on the outside of the cell. But we're going to actually be moving those against the concentration gradient. So even though there's lots of sodium on the outside of the cell, we want to push more sodium out there. Okay, so that's what our cells do, and let me show you another diagram. This one I like because it actually shows you step by step by step, and it also shows you that it's using energy. So if you look here, here's our protein, here's our membrane, outside, inside. So 3 sodium molecules are going to come in and bind to this protein, okay? Then a ATP, here's our little ATP molecule, is going to come along and it's going to bind to that protein. Okay, so here's our protein, it's open on the inside. Once those sodium molecules and the ATP binds to it, it's going to cause that protein to change shape. So it's going to cause it to actually open up like this so that it's exposed to the outside of the cell. So those sodiums are going to leave that protein, and now it's open and available for the potassium ions. So if you look on number 3, there's 2 potassium ions that are binding to the inside of that protein, okay? Once those bind to it, it allows the protein to change shape again. So it's going to then close and then open up so that it's exposed to the inside of the cell, and the potassium ions are going to move in, the little piece of the ATP molecule is going to come off, and now it's available for it to happen all over again. Okay, so that is an example of a protein pump. Like I said, that's a really popular one that scientists use because it's pretty common. Lots of cells have those pumps, if not every cell. And it's a really good way to show things moving against the concentration gradient with the use of an ATP molecule. Specifically on the test, I'm not going to ask you to step-by-step explain how this happens, but overall I do want you to know the concept of against the concentration gradient with the use of energy. The other example of active transport is bulk transport. So this is talking about the movement of really big packages of molecules, okay? When you go to Sam's or to Costco or to any one of those stores, you're buying in bulk. You're buying really big packages of chicken or diapers or, I don't know, Lysol wipes or whatever you go there to buy. Okay, you're buying lots of them at the same time. Well, you're buying in bulk. Bulk just means big, okay? So some things, like the packages of proteins that the Golgi apparatus makes, are too big to fit through the membrane by themselves. So what's going to happen is the membrane's actually going to have to form or fuse with vesicles to be able to push those really big packages across the membrane, okay? And because they're so big, it's going to use lots of energy to move those into or outside of the cell. So when we're moving large bundles of molecules into the cell, it's called endocytosis, endo meaning into, and moving large bundles of molecules out of the cell, for instance, from the Golgi apparatus, is called exocytosis. Exo, exit, moving out. So here I have a picture showing both of those. If you look here, here's a really big molecule, too big to move even through a protein. It's actually probably a protein itself, okay? So this is a really big molecule and it needs to get into the cell. So what's going to happen is that cell membrane is going to start to wrap around that molecule until it forms a vesicle, and then it's going to pull into the cell. So here we have that molecule moving in, it's forming a vesicle from the cell membrane, and then it's going to move into the cell. And here actually you see that this is a lysosome. And remember, lysosomes digest things, so this lysosome is going to fuse with that vesicle and it's going to start to break that molecule down so that the cell can use it for what it needs to, okay? On the other hand, we have something that's moving out. So this is endocytosis, this is exocytosis. So here we have, it looks like, here's our rough endoplasmic reticulum, the smooth endoplasmic reticulum, ribosomes on it. These ribosomes are going to be making the proteins, it's going to move through the ER, then it's going to package those proteins or whatever it's making up, and it's going to move it into the Golgi apparatus. So this one, it looks like it's making lipids. On this side, it looks like it's making a protein. So that protein is going to move into the Golgi apparatus, and remember that Golgi apparatus modifies, and it packages, and it gets ready to ship it out of the cell, okay? So here we go. Here's our package that's about to be squeezed off of the Golgi apparatus. Then it's going to move to the cell membrane, and that cell membrane is going to actually fuse with that vesicle, and it's going to open up, and then it's going to push that big protein out, okay? So that protein is going to be secreted, and it's going to go to whatever part of the body that it needs to and work on those cells. Okay, so that's the process of exocytosis, pushing really big molecules out of the cell. So we just talked about a couple of really important things We talked about active transport, which means it uses energy. We talked about how things move against the concentration gradient with protein pumps. We also talked about how really big packages move into or out of the cell. All right, so not as much as what we talked about with passive transport, but still a lot of important concepts. And I really hope that you wrote down any questions that you might have. Definitely we can talk about this in class. We'll do lots of practice kind of things, but you need to make sure you got this, all right? Thank you.